Okay, divide this function by x minus 3. So if we divide by x minus 3, we can use synthetic because it starts with a 1. So synthetic division, we're going to put 3 in the box, and then we're going to go in descending order 2, negative 3, negative 3, 6. Okay, now you bring that down, so that's 2, then you times these, that's going to be 6, add them up, that's 3, times them, that's 9, add them, that's going to be 6, times them, that's 18, add them up, that's 24. Okay, this is my remainder right here. So my remainder is 24, and you can, this question right here, the remainder theorem, you can actually find the remainder if you evaluate the function in place of x. If you were to plug in 3, so the number that goes in this box, the number that goes in the box, if you take 3 and plug it in for these x's, so 2 times 3 cubed minus 3 times 3 squared minus 3 times 3, that will give you a 24. So the remainder theorem says whatever you put in this box, if you plug into the function, it will spit out the remainder. Okay, place the red dashed parabola to show the function f of x minus 2. So minus 2, that's going to be the k. If you minus or add outside the parentheses at the very end, that's a vertical shift. So the red one should be down right here. So it should just come down 2 times. The blue one, if you add or subtract in the parentheses, that's the h. And that is a horizontal translation. So if it's x plus 3, remember in the parentheses there has to be a minus. So that 3 is really a negative 3. So that means we're going 3 to the left. So take this black one and slide it 3 to the left, and that's going to look like that. Okay, 19, the quadratic expression, the terms, the factors, and the coefficients. Alrighty, the terms, the factors, and the coefficients. Okay, the terms are the 3 separate pieces. So there's a piece, and that is actually a negative 8. So terms are separated by plus signs. So if you expand this out, it really is 3x squared plus 5x plus a negative 8. So the term, I see a 3x squared, so 3x squared is a term, and I see a 5x, that's a term, but I don't see a negative 8. There should be 3 distinct terms. Okay, the coefficients are how many squares you've got. So 3 is a coefficient, and how many x's you've got. 5 is also a coefficient. Negative 8, this is a constant. That's just how many 1's you've got. So if you have 5x's, x, 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 x. If you've got negative 8 1's, that's negative 1, negative 1, negative 1. You got 8 of them. So the 1's are the constants. Okay, the factors, I'm not really sure what they're saying. I'm not sure what they want for the factors. So this question kind of might be a little bogus. So we're missing a negative 8 for one of the terms. Oh, the factors, you've got to rewrite it as a times problem to find the factors. You got to factor it. So this might actually be a cool problem. So to find the factors, the only way you can find the factors is if you are looking at it as a multiplication problem. So let's factor this. Now, to factor it, if it doesn't start with the 1, then it's a little tricky. I'm going to take the 3x squared, and I'm going to take and break up the middle. So we're going to break up 5x's. So we're going to write it as 4 terms instead of 3. So I'm going to take my first and my last, and I'm going to times them, and that's a negative 24. Okay, now I'm looking for something that times and gives you negative 24, but adds and gives you 5. So that is going to be a negative 3x and a positive 8x. So now if I factor these, I'm going to divide both these by 3x, so it's going to be 3x times x minus 1. If I divide both these by 8, it's going to be 8 times x minus 1. So now it's going to be 3x plus 8 times x minus 1. So the factors, that is a factor, 3x plus 8 and x minus 1. So it's almost perfect if we just had a negative 8 there. 20. So Kayla used the quadratic. Let's solve it. Let's solve for x. X equals, so I am missing the bx. If you're missing the bx, just undo the operation. So I'm going to undo plus 2. I'm going to minus 2, minus 2. So I got 2x squared equals minus 2. I'm going to undo times 2, divide that by 2, divide that by 2. So I got x squared equals a negative 1. Undo the square root, so it's going to be plus or minus I. Square root of negative 1 is imaginary. So x equals a plus 1i or a minus 1i. Okay, so we got a graph with 3 separate lines going on, and they are inequalities. So some of them, we need to shade them. So A wants to know which of these boundaries should be solid instead of dotted, and this is the one that should be solid right here. So the x is less than 5. That's this vertical line right here. X is less than 5 because it's going through the x-axis at 5. So that one's easy. This one's going to be easy. This one has a y-intercept of 4. So that's this guy right here. So this is y is greater than or equal to a negative 2/5 x. And this is the one that should be solid. So this boundary line should not be dotted. It should be solid all the way through. Okay, now B. So A is done. B. We need to figure out where the solution is going to be the region that meets all 3 of these lines. So this guy right here, let's do this vertical line. X is anything less than 5. So that is going to be anything on this side of the line. Okay, now this one, the answer is y is anything greater than this line. So greater than this line is anywhere above that line. And then the top one, okay, I need to solve for y. So I'm going to take the 2x over. So it's going to be a negative 3y is less than a negative 6 minus 2x. I'm going to divide by a negative 3, and you're going to divide by a negative 3, and what you need to know is the moment you divide by a negative 3, you need to change the direction. So this line right here, this line goes to this guy right here, and y is anything greater than, so it's going to be anything above this line right here. So the region that they got in common, it's got to be above this line. So it's got to be above this line, it's got to be left of this line, and it's got to be above this line. So the region that they have in common is going to start right here. and it is going to be anywhere in between here. That's left of the vertical line, it's above this guy, and it's above this guy. So that is your answer right there. That's the region. Okay, 22. On the number line, show the x intervals where the function is increasing. So it's where it's growing, and that is anywhere from here. It's where it's got a positive slope. So it's got a positive slope from here to here. So on the x, so from here to here, it's increasing. So I'm not sure what we want. How do they want us to show that? Use the connect tool. Place excluded below any endpoint. Ooh. I'm not sure how to manipulate this, but it's increasing from here to here. That dot all the way up, it's going to have a positive slope. So how do we show that on the number line below? So the number line below is going to be from here on, it's increasing. Oh, so I think, and then we're going to from here to here, so it's between there. So the question is, so you got a dot, is it shaded and then, and is this one shaded and then like that, or is it empty and is that one empty? So is that what they're talking about? Place excluded below any endpoint that should be open. Yeah, and included should be below anyone that's filled in. So on your number line, okay, is it increasing on this number? And is it increasing right there? It stops increasing. So this one should be circled and empty. It should not be shaded because it stops increasing right there. But this one down here, it looks like it's gonna go, that arrow means it keeps going all the way to infinity. So our picture is gonna be a little bit different. Alright, I think I figured out what they want. So right here on the number line, what is that? Like a -2? There we go. It is going to be increasing anywhere left of -2, not including -2, and it's going to be increasing anything greater than 3, but not including 3. 3 is where it turns around and starts to increase, so it should look like this. So we'll put excluded here and excluded here. Okay, the function is a piecewise function. Place one expression in each box to complete the function. So here we go. They want you to look for when x is smaller than or equal to 1. So on your x number line right here, here is 1. So anytime x is this side of 1, anything to the left, so you're going to be looking at this line right here. This line is a linear function, and its y-intercept is a -3, and the slope is going to be, what are they doing? They're going up 1 over 1, up 1 over 1, up 1 over 1. So the y-intercept is a -3 and the slope is a -1. So that's going to be this guy right here. So that is describing that line. And anytime x is greater than 1, so here's 1, x is bigger than 1 is this way, so that's going to be this line right here. And this line doesn't look linear, it looks like it's got a curve. So if it's not linear, it's not going to be any of these. So I'm going to go with this one. A radical x plus 2, because I know the negative would flip it upside down. So this is going to be radical x plus 2. And you can punch, type these in on your calculator and look what the graph looks like and see which one's going to be the better one to pick. But I know this negative is going to flip it upside down, so it would look something like that. Okay, 24. So make your own graph that has a constant rate of change of 1, where your domain is x is anything greater than 0. So the x number line, you've got to do anything greater than 0. So from here on, and the range, anything greater than 2. So they're creating a window, and the window that they just created is right here. So in this region here, because y has to be anything bigger than or equal to 2, and then the x has to be anything greater than or equal to 0. So kind of quadrant 1. Now graph a function with a constant rate of change of 1. So you just put a dot anywhere you want. If there's more than one right answer, and then you just go up 1 over 1, up 1 over 1, up 1 over 1. So this line right here will meet the criteria. 25. Let's figure out which ones are equivalent to 25 to the 3/2. This one will be, this one will be, this one will not be, this one will not be, this one will not be, and this one will not be. Okay, B. Drag digits in the boxes to evaluate. So let's evaluate 25 to the 3/2. Break up a number, break up 25 and change it for 5 squared. So if you've got 5 squared to the 3/2 times your exponents, so it's going to be 2 times 3/2, so that will be 6/2, which is 3. And 5 cubed is 125. So 1, 2, 5. Okay, this is a good question. They want you to check the boxes of any of these scenarios that will fit a domain of just being positives. So the domain can only be positive integers. So it can only be 1, 2, 3, 4 to infinity. No decimals, nothing in between. Okay, this one will not work because the height of a ball at a specific time, you can have time as 1 second, 2 seconds, and 3 seconds. But there's going to be time in between them, 1.5 seconds. How high was the ball at 1 and 3/4 seconds? So that one's not going to work. Converts Fahrenheit to Celsius. That's not going to work because you're going to have degrees in between degrees, 32.3 degrees. And this says you can have no numbers in between them, just integers. That's no good. Cost of a bag of fruit based on its weight. Okay, this one's kind of tricky, but I think this one's no good too. Because I think if you put weight here, And cost here, this is the domain. The domain is your x. So the weight, there can exist like 1.5 pounds. That can exist, so that's no good. A student's height in inches and gives the weight. So that's the same thing. If you do height here and weight here, a student can be 55.5 inches. So that's no good. Okay, these bottom two I think are going to be the ones that they want. So money based on sales of an item. So if you're selling vacuums, you cannot sell 2.5 vacuums. Every vacuum you sell's got to be a whole number. So that one makes sense. And the cost of a field trip based on the number of kids, yeah, you're only going to have a whole number of kids. 1, 2, 3, 4, 5 kids. You can't have 5.5 kids. So it's the bottom two that makes sense. So you got a formula. Y equals 500 divided by x plus z. Calculate the value of a quantity y given the values for x and z. He then rearranged the formula. Okay, this is a good one. So he wants to solve for z. Z is in the bottom of a fraction, so that's lame. You need to times both sides by x plus z. Times this side by x plus z. And if you times that, that will kill that. So now you just got 500 equals x plus z times y. Now I want the z by itself, so let's ditch this y. Divide by y, divide by y. So now I got 500 divided by y equals x plus z. Ditch the x minus x minus x. So it's going to be 500 over y minus x equals z. So z equals 500 over y minus x plus a negative x. Check them all, they're going to give you 24. 6 square roots of 2 does not give you 24. 2 square roots of 6 squared is going to be 2 square roots of 6 times 2 square roots of 6. That's going to be 4. That's going to be square root of 36, which is 6. 4 times 6 gives you 24. That one's good. Square root of 48 over 2 is going to be the square root of 24, so that's not going to work. 4 square roots of 6 times 4 square roots of 6 is going to be 16 times 6 divided by 4. And 4 is going to go into 16 4 times, and 4 times 6 is 24, so that one won't work. The square root of 24, that is like 24 to the 1/2 raised to the 1/2. So times your exponents, so that's 24 to the 1/4. That's not 24. And this is 24 to the 1/3 cubed. That will be, because 1/3 times 3 is just 1. So 3 out of the 6 will give you 24. 29. Find the zeros of the function. Okay, factor it. And it doesn't start with the 1. So let's take 2x squared and let's create a polynomial with 4 pieces instead of 3. So times your first and your last. Is this the one we just did? 2 times negative 12 is negative 24. What times this gives you negative 24? I can give you negative 5. It's going to be negative 8x and a positive 3x. So now group them. Group these two, divide them both by 2x. So it's going to be 2x times x minus 4. Divide these both by 3. So it's going to be 3 times x minus 4. So if you factor them, it's going to be x minus 4 in one group, and your other group is going to be 2x plus 3. So your zeros will be a 4 and a negative 3 halves. Because 2x minus plus 3 equals 0, minus 3, minus 3. 2x equals minus 3, divided by 2, divided by 2, so it's going to be minus 3 halves. So it is a plus 4 over 1, or it's a minus 3 over 2. Okay, the roots of x squared after you shift it 3 units left and 1 unit down. So x squared, if you shift it 3 units to the left, I guess it's going to be this. X minus 3 to the left is going to be a negative 3. And then 1 unit down is going to be minus 1. So, that is going to be x plus 3 squared minus 1. So that's going to be x plus 3 times x plus 3, which is x squared plus 6x plus 9 minus 1. And that is x squared plus 6x plus 8. Okay, the zeros are easy to find if you can factor it. So I'm going to factor this to x plus 2 times x plus 4. So my zeros are going to be a negative 2 and a negative 4. So a negative 2 and a negative 4. Vertex, the vertex is at a negative 3 and a negative 1. That's your h, that's your k. And your h and your k is the same as your x and your y. So your vertex is going to be left 3 and down 1. Alright. Long division. So, what do we got to do here? You may show work in the space. Be sure to place a 0 in a box. Okay. So, do we got to divide this by this? Alright, I think we do. She's polynomial line division to divide, blah 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 blah. So we just gotta complete the quotient. Okay, so I think what are we gonna times x squared by to turn it into x cubed? And that should just be x, because an x times an x squared is going to be an x cubed, but an x times a 1 is just an x. So, now if I minus these, I'm going to minus this and minus this. Those are done, but x cannot play with the x squared. So I'm going to bring this down. So 3x squared. And what am I going to times x squared by to turn it into 3x squared? I'm going to times by 3. So 3 times x squared is going to be 3x squared, but I got to times it also by this 3. So now I got to minus them. So that is gone. That's 0. I got to minus this. But now look, I still got this minus x hanging out over here. So this minus x is going to play with this negative 8x. So if I bring this negative 8x down and this negative x down, that's like a negative 9x. And if I got my 5 here, my 5 is going to play with the negative 3. So my x's, these and these, that's going to be a negative 9x. And my 5 and my negative 3, that's going to be a 2. So, man, I don't even know what they want you to do. So we got our x plus 3 right here. That's the x plus 3. Because I don't know what you're going to times x squared by to turn it into a negative 9x. X squared times what is going to give you a negative 9x? Oof, man, I don't know. This question has got me stumped, so I'm just gonna call it good.